In this video, I want to go over rational expressions. First, I want to go over what a rational expression is. Then I want to go over some domain restrictions involved with them, the simplification of them, and then multiplication and division of rational expressions. Okay, so the first thing is, what is a rational expression? Well, it's just a ratio of two polynomials. So if p of x is one polynomial and q of x is a different polynomial, and as long as q of x is not equivalent to 0, then this is a rational expression. Okay, so an example would be just some quadratic on the top, maybe x squared minus 49. And something on the bottom, it could be a quadratic, could be quartic, could be whatever you want. I'll just make it be x plus 1. This is a rational expression. Okay, it's a ratio. Okay, that's where they get rational from. Okay. So, now that you know what one is, let's talk about the domain restrictions. Here that I said that q of x cannot equal 0. Okay, that'll give you that dreaded division by 0 issue. So let's talk about it. I have two examples here. Example A is 8 over x plus 3. Now this is a pretty simple example. You might just automatically know that, okay, negative 3 is going to give us a 0 on the bottom. But I want to do it very formal and then show you two different ways to display the domain restriction. Okay? So formally what you would do is you would set the bottom, set the denominator to 0, and solve. Okay, so that's what I'm going to do. X plus 3 is equal to 0. And this is going to give you what x cannot be. All right? So x cannot be negative 3. Okay, you can write your domain restriction in a couple of different ways. You could just simply say this, x cannot equal 3. That's sort of set builder notation. Okay, I'm not going to go fully in depth with set builder notation until a little bit later. But you could just say x cannot equal 3. Okay, or you could express it in what x can be. Okay, so you can write it as the domain, excluding the restriction, is negative infinity to negative 3, and then negative 3 to positive infinity. Okay, so this just excludes negative 3. If you remember, square brackets means includes, and rounded brackets means doesn't include or excludes. Okay? And this type of notation, so this is sort of set builder notation, sort of set builder. And this notation is called interval notation. Okay? Let's do the next example here. Question B. I want to know the domain restriction of 5x over x squared plus 2x minus 63. Okay, again, we're just dealing with the denominator. Okay, the numerator doesn't matter. As far as listing off domain restrictions, the numerator does not matter. Okay, so the first thing I'm going to do is I'm going to set the bottom, x squared plus 2x minus 63, equivalent to 0. Okay, you know how to solve this. You can use whatever method you want, quadratic formula, guessing and checking, AC method, whatever you want. I'm going to use guessing and checking because I see a negative 63 here. I know it's going to be 9 and 7, 9, 7, and the smaller one is going to be negative. Okay, so in this instance, x cannot equal 7 and negative 9. Okay, either one of those numbers is going to set the bottom equal to 0. Okay, so you can this is again sort of set builder notation, okay, where you're just listing off the domain restrictions. X cannot be. It's basically all real numbers except for 7 and negative 9. Or we could write it in this interval notation. The domain of this expression is, this is going to be a long one. Let's see if I can write it small. Negative infinity to negative 3, not including negative 3. And remember, you never include the infinities, okay? They're always rounded brackets. Negative 9 to 7, not including 7. And 7 to positive infinity. Okay? So this is our interval notation of the domain restriction. Or, including the... It's our domain, actually, and it's not including our domain restrictions, okay? All right, let's go on to simplification, okay? You can cancel things out from both the top and the bottom. However, you have to make sure, okay, that when you do this, you list the domain restrictions first before you cancel anything out. That simplification without listing a domain restriction could make the problem wrong, or could make the expression into a totally different expression. So let's try to simplify this A here, and we'll see what happens. Okay, so I can take out next to the third on the top, and I'll be left with x plus 1 on the top and x plus 1 on the bottom. Now, you're going to be very tempted to cancel those out, and you should. You should cancel these out. However, you have to make sure that you list that domain restriction. You have to make sure that you know that x cannot equal negative 1, okay? So this rational expression can be rewritten as x to the third, and that's exactly what it looks like. It looks like x to the third, except x cannot equal negative 1. Okay? If you remove that restriction, okay, it makes it a totally different problem. It makes it just x cubed. This is x cubed with the caveat that x cannot equal negative 1. Okay? So there's a little blip on the function, I guess, if you made this into a function, on the function at negative 1, that the function does not exist at that point. Okay? Let's do example number 2, or B. Okay, so factor the top, factor the bottom. So the top, that's a difference of 2 squares. So that's going to be x minus 6 times x plus 6. Okay? And the bottom, I have a 30, both positives, so that's going to be a 6 and a 5. Right? That adds up to be 11. Okay. So here, again, you're going to want to cancel out these x plus 6's, and you're right to do so. However, you have to make sure to write both domain restrictions, okay? So this can be simplified to x minus 6 over x plus 5. However, you have to make sure to include that x cannot equal 5 or negative 5 or negative 6. If you don't include that, it's wrong. It makes it a totally different expression where you can plug in negative 5 and negative 6, okay? Because there's nothing here anymore in the simplified thing that would tell you that you can't. But your original problem wanted it where you could not plug in those numbers. Okay? Moving on to multiplication. Okay, very, very similar. All we want to do is let's factor first. Factor everything out, then cancel stuff out. And then we'll just make sure to have those domain restrictions in there. Okay, so on the top here, this is a difference of squares, so this is x minus 1 times x plus 1. And on the bottom here we can take out a 3, and that's going to be an x minus 7. Okay? So now, on the bottom here, I want to make sure, because I know I'm going to cancel out a negative, I'm going to cancel this out and I'm going to cancel this out. So I need to make sure to list those as domain restrictions, okay? So I know that I'm just going to list them up here. X cannot equal 7 and 1 and 7, okay? Now back to the problem. Okay, I'm going to cancel out this x, I'm going to cancel out this x minus 1 and this x minus 1, and this x minus 7 with this x minus 7. I'm going to be left with an x plus 1 over 3. However, I need to make sure it's not exactly x plus 1 over 3, it's x plus 1 over 3, but you can't plug in 1 and 7. Okay? And that's my answer. Now, division is a little bit trickier, okay? I want to show you guys maybe another way to look at this division problem before we move on to it. So you have to write down all the domain restrictions. And the domain restrictions are actually going to be here, here, and here. And I want to show you why. If you were to write this problem as x squared minus 2x minus 8 over x squared minus 9, and then a big division sign, right, a big division sign here, over x minus 4 over x plus 3, you can kind of see that if x squared minus 9 is equal to 0, that's going to give us a division by 0 error here. Okay, so that's no good. So this x squared minus 9 cannot be 0. If this x plus 3 is 0, then that's going to give us division error by 0 error here. Okay, and that's no good. So we can't have an x plus 3. Okay, that takes care of that one. But also, if x minus 4 is equal to 0, that'll make this entire thing 0, and I'll have a division by 0 error in the big fraction. So again, x minus 4 cannot be 0. So those are the 3 spots on a division problem that you cannot have, that you have to look out for your domain restrictions. So here, our domain restrictions are going to be, well, here it's going to be plus or minus 3. So domain restrictions is x cannot equal plus or minus 3. That takes care of this one, and also 4. Okay, so those are the domain restrictions we have to take into consideration. Now let's do the problem. I'll erase a little bit of this. Okay, so I'm going to factor everything. The top left is going to be x minus 4 times x plus 2. The bottom here, as we said, was x plus 3, x minus 3. I'm going to I'm going to change the sign and flip the fraction to be x plus 3 over x minus 4. If you remember that rule, keep, change, flip for division of fractions. And then I can cancel stuff out. So I'm going to cancel out the x plus minus 4s and the x plus 3s. So I'm going to be left with my final answer of x plus 2 over x minus 3. However, I know that x cannot equal plus or minus 3 and 4. Okay, and that's how you solve them.